So now we've done example 2, let's try example 3, also known as example trace. And we're going to turn this into a trig form. So if you are given that z is equal to 6 minus 6i, that is the same thing as having the ordered pair of 6 comma negative 6. So that means you go to the right 6, down 6, you're going to be in quadrant 4, so your theta needs to make sure you are in quadrant 4. So let's find out what your r is. Well, that is just by taking a 6 squared plus negative 6 squared, which is radical 36 plus 36, also known as a radical 72. And some of you may stop there, but haha! It is actually a 6 radical 2 when you reduce it. So there's your r. So now to figure out what your theta is, you take the arctangent of negative 6 over 6. And that's the same as saying the arctangent of negative 1, which ends up being a negative pi over 4. Interesting. Negative pi over 4, which is the same as, think about it, if you are in quadrant 4, and here's your grid, and you go over to the right 6, 1, 2, 3, 4, 5, 6, you go down 6, 1, 2, 3, 4, 5, 6, well, that means you'd be at the point over 6, down 6, which is right here, and that is, the angle it's going to give you is this negative 45 degrees in here, or negative pi over 4, which means to go from there all the way around your circle to this point, that is the same as having 315 degrees. So I don't care if you write it as 315, I don't care if you write it as a 7 pi over 4. I'd probably recommend writing it in terms of pi, but we won't get too technical. So then when you write your trig form of your complex number, you're going to have a 6 radical 2 times your cosine. Your theta is a 7 pi over 4 plus I sine of 7 pi over 4. Hee hee. There is your solution. And why is it doing that? It's so slow. There's your answer. Enjoy example 3.